Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you very much. I'm Philip Emeagwali. At 8:15 on the morning of the 4th of July 1989, the U.S. Independence Day, I saw something that had never been seen before. By seeing something where nothing existed, the discoverers and inventors made darkness visible. The inventor embarked upon a hero's quest to hear something that was previously unheard, to see something that was previously unseen, and to understand something that was previously misunderstood. Trying to understand an invention without the life story of its inventor is like looking at an embroidery from the wrong side of the cloth. On that U.S. Independence Day in Los Alamos, New Mexico, United States, I made the first experimental measurement of the world's fastest computation ever recorded across an ensemble of processors that is a new internet. That invention represents a new way of looking at the computer. To be the first is a greater achievement than to be number one or to be the fastest. There's only one first, but there will be many fastest. I was the first to discover that parallel processing across an ensemble of the slowest processors is faster than sequentially processing only on the fastest processor, or doing so only on the fastest supercomputer. Back in 1989, it was my most pleasurable experience to be the first person ever to stand at the farthest frontier of human knowledge and see the massively parallel processing supercomputer that is the precursor to the modern computer. On the night of the 4th of July 1989, I had a powerful, unsettling dream. I woke up with the visceral feeling that I had permanently entered into the history book and into school reports. I witnessed the birth cry of a new computer that is a new supercomputer, that is a new internet, that is outlined as a new global network of 65,536 tightly coupled processors that were identical and equal distances apart. Each processor operates its own operating system. Each processor has its own dedicated memory that shares nothing with each other. I trembled because I saw a supercomputer that no human had ever seen before. I saw an ensemble of the slowest processors in the world outperformed the fastest supercomputer in the world. I got goosebumps and my hairs stood on end while I watched my invention unfold. Seeing for the first time ever the slowest processors compute together to compute faster than the fastest supercomputer was the most amazing experience in my life. I trembled because I was witnessing the birth of a new era in the history of the computer. I trembled because I was witnessing a paradigm shift in the supercomputer world. I trembled because I was witnessing a change of tectonic proportions that will forever affect the way our distant descendants of a million will think about their version of the computer. I trembled because my dreams and my illusions had become reality. I got goosebumps because I was gazing across the centuries and into 1,000 millennia. That 4th of July 1989 marked the moment we changed the way we looked at the modern supercomputer and changed the technology from an old computer that computed with only one electronic brain to a never-before-seen supercomputer that executes the fastest computations and compute them across a never-before-seen internet that was outlined by millions upon millions of electronic brains. That 4th of July 1989 marked the moment when, for the first time ever, an ensemble of the slowest processors computed together and computed as one seamless, cohesive unit, and computed faster than the fastest supercomputer. For me, Philip Emeagwali, that 4th of July 1989 was a day of fire. The day the massively parallel processing supercomputer became the fire we can't put out. After my discovery on that day, trying to stop the acceptance of the massively parallel processing supercomputer became like trying to stop midnight. I experimentally discovered that using only one processor to solve the toughest problems arising in extreme scale computational physics was like putting the wings of a jet aircraft upon an ocean liner. My paradigm shift was from computing in the singular to both simultaneously computing and communicating in the plural senses. The need to calculate is as old as humanity. The need to compute existed because it is central to human existence. On the 4th of July, 1989, I witnessed the unveiling to the human race of a new understanding of the words computer and supercomputer. As an aside, the Latin equivalence of the word computer was first used in print 2,000 years ago. The word computer was first used by the Roman author Pliny the Elder. The word supercomputer was coined in 1967. I believe that our children's children will coin a new word for their supercomputers. I believe that our children's children will invent supercomputers that are science fiction to us. I discovered that inventing a new technology creates a need for a new vocabulary and a new narrative for the histories of science and technology. The invention of the massively parallel processing supercomputer is the single most transformative technology and the biggest advance in physics since Newton Galileo. The computer is integral to human civilization. The computer is the greatest invention of the 20th century. Parallel processing is the biggest advance in the history of the computer. We have changed the way we think about the computer from computing with only one processor to supercomputing across millions upon millions of processors. Back in 1990, I made headlines in major US newspapers because I had invented something new, namely a new internet that is a new supercomputer de facto, but that is not a new computer per se. That internet could have been invented earlier, but was not. Fire is man's first invention, or rather man's first discovery. The computer is the greatest invention since fire was discovered. The modern supercomputer is the greatest invention in modern physics. The computer was invented not because we did not know how to compute. The computer was invented because we needed to compute faster and sometimes to compute infinitely fast. And the supercomputer is the fastest computer. The modern supercomputer is a tool that enables the mind to go where the eyes cannot see. To invent a never-before-seen supercomputer is to turn fiction into fact and do so by computing at unheard of speeds and supercomputing to solve grand challenge problems arising in extreme scale computational physics and that were otherwise impossible to solve on existing supercomputers. That was the reason I was in the news headlines back in 1989. I'm Philip Emeagwali, a child soldier on the Biafran side of the Nigeria-Biafra War, a war that raged during the last 30 months of the 1960s, a war that was described as Africa's bloodiest war, and a war in which 1 in 15 Biafrans died. My 20-year-long journey began at a war front in July 1969 and ended at the frontier of knowledge. The turning point in my journey to the frontier of the most massively parallel processing supercomputer occurred 20 years before my experimental discovery of the massively parallel processing supercomputer that in turn occurred on the 4th of July 1989 in Los Alamos, New Mexico, United States. In July 1969, I was conscripted as a 14-year-old soldier and sent to the Oguta War Front, Igbo land, Biafra, West Africa. I was the youngest soldier there. That war turned my ancestral homeland into Africa's bloodiest battlefield. I arrived at the Oguta War Front a few days after 500 Biafran soldiers fell on the ground. 500 soldiers fell as if they were dry leaves. I was conscripted to replace one of these 500 men. At the Oguta War Front of Biafra, there were more guns than pens. That 30-month-long war ended on July 15, 1970, with the defeat of Biafra. A 12-year-old writing her school report asked for a little-known fact about Philip Emeagwali. I asked her, what else does Philip Emeagwali have in common with the German-born theoretical physicist Albert Einstein, or with the South Sudanese-born supermodel Alec Weck, or with the South African-born singer Miriam Makeba, or with the South African-born novelist Nadine Gordimer, or with the Haitian-born former Governor General of Canada, Michael Jean? The answer is that we were all former refugees who were featured in a school poster. That school poster was titled, Refugees You May Know. Because of that refugee poster, I received letters from Somali refugees in Kenya, from refugees from the Democratic Republic of Congo, from refugees in Ethiopia, from refugees in Burundi, Rwanda, and Liberia. That refugee poster was produced and distributed by the United Nations. According to the United Nations, 65 million persecuted people were forced to flee from their homes and forced to flee from civil wars and forced to flee from areas that were afflicted with severe food shortages. For 3 years of the late 1960s, I was a refugee in Biafra who mostly lived in classrooms that were converted into living rooms. For 3 years, all schools in Biafra were closed and converted into makeshift overcrowded housing and feeding centers for millions upon millions of Biafran refugees. In early 1968, Russian MiG-17s, the same high subsonic fighter aircrafts that were heavily used in Vietnam, and Russian Ilyushin 28 bombers paid us regular visits in Onitsha, Biafra. From the inland town quarters, Enu Onitsha, of Onitsha, and on Wednesday, March 20, 1968, we saw Biafran soldiers fleeing on foot from Abagana war front. Abagana was a 5-hour walk from our residence. It was from fleeing Biafran soldiers that we learned that my ancestral hometown of Onitsha, Nigeria, would be captured in 6 hours. We knew the Nigerian army did not take prisoners. We had learned from the dance of death of October 7, 1967, in Asaba, Nigeria, that 700 unarmed civilian men were murdered. So we knew to flee immediately. we fled from 14 Mba Road, Umudei Village, Onitsha, Biafra, the residence of my uncle John Emeagwali, to Merchants of Light School, Oba, Biafra. That flight from Onitsha was the last time I saw John Emeagwali's residence. That was at 14 Mba Road, Onitsha. That residence that was built 6 years earlier was ground zeroed by either a bomb or a rocket or a cannon fired by the Nigerian army. Please allow me to quote from another eyewitness account what happened in Onitsha, Biafra on the night we fled. This eyewitness account was titled Nightmare in Biafra. This eyewitness account of the night of March 20, 1968, that we fled Onitsha, Biafra, appeared in the Sunday Times of London, England, on page 12, April 26, 1968. And I quote, "I have seen things in Biafra this week which no man should have to see. Sights to search the heart and sicken the conscience. I have seen children roasted alive, young girls torn in two by shrapnel, pregnant women eviscerated, and old men blown to fragments. I have seen these things, and I have seen their cause, high-flying Russian Ilyushin jets, operated by Federal Nigeria, dropping their bombs on civilian centers throughout Biafra." End of quote. The war correspondent who wrote the article, Nightmare in Biafra, continued, and I quote, "At Onitsha, under siege from the federal troops, the 300 congregation of the Apostolic Church decided to stay on while others fled and to pray for deliverance. Colonel Mohammed's 2nd Division found them in the church, dragged them out, and tied their hands behind their backs and executed them." End of quote. My ancestral origin is from the Igbo-speaking people of southeastern region of Nigeria. According to an Igbo proverb, a new fowl in a new land looks at the old fowls to learn how to crow in their new language. I, Philip Emeagwali, was the new fowl in the then unknown land of the modern supercomputer. I was the new fowl in massively parallel processing supercomputing who did not look at the old fowls in vector processing supercomputing. I did not learn from the old fowls how to invent a never-before-seen internet that is a new supercomputer de facto, but that is not a computer per se. Parallel processing was scorned as a beautiful theory that lacked experimental confirmation. I began supercomputing when I was only 19 years old. I began supercomputing at 1800 Southwest Campus Way, Corvallis, Oregon, United States. When I began supercomputing, I was new in the United States, having arrived on March 24, 1974, after receiving a scholarship letter that was dated September 10, 1973. Who is it that can tell me who I am. I am Philip Emeagwali, born on August 23, 1954, in Akure to Igbo parents who were living in the heart of Yoruba land. I was born in the then British West African colony of Nigeria. In a sense, my story began in the faraway United States 7 years before I was born, in the August 25, 1947 issue of the New York Times that carried an article titled, quote, "New Giant Brain Does Wizard Work," unquote. That New York Times article explained that, and I quote, "The machines under construction will have a built-in intelligence which will enable them to handle the most complicated differential equations of physics and engineering, performing hundreds of separate mathematical operations without the intervention of a human operator," unquote. 43 years after that big question was posed in the New York Times, I solved the problem that was listed by the United States government as one of the 20 grand challenges in supercomputing. For that breakthrough, I was in major US newspapers, such as in the June 20, 1990 issue of the Wall Street Journal. I was in the news because my invention of the massively parallel processing supercomputer that occurred on the 4th of July 1989 was an invention of a new supercomputer with built-in intelligence that solves the toughest partial differential equations arising in physics or in extreme scale computational fluid dynamics. The poster boy of these grand challenge problems is the general circulation model that must be used to foresee otherwise unforeseeable climate changes. I was in the news because of my invention of how to send and receive 64 binary thousand email messages and how to do so across my ensemble of 65,536 tightly coupled processors. I was in the news because of my invention of how to perform the world's fastest supercomputer calculations ever recorded and how to always record a world record speed in supercomputing and how to do so across a new global network of processors that is a new internet and a new supercomputer and a new computer. A discovery or an invention is like the moon. It has two parts, the visible part and the hidden part. For that reason, I am well known, but I am not known well. A 12-year-old asked me, "I'm doing a school report on the development of the computer. Why are you called the father of the modern computer that solves many problems at once?" I answered, "The computer has many fathers and mothers, uncles and aunts. But I am the only father of the computer who was profiled in major US newspapers and who was credited for the invention of the massively parallel processing supercomputer. I was in major US newspapers because I made the first experimental measurement of the world's fastest computation because I made the first experimental measurement of the world's fastest computation ever recorded across an ensemble of the slowest processors in the world. The reason my invention of the massively parallel processing supercomputer was written about in major US newspapers was that it opened the door for speeding up 30,000 years of time to solution on one computer that computed with only one processor to just 1 day of time to solution on one supercomputer that simultaneously computed across a tightly coupled ensemble of 10 million processors. At its core primordial essence, my quest for a never-before-seen supercomputer aimed to change the way we solve the toughest problems arising in calculus and algebra, and to change that way from solving the toughest problems on only one computer powered by only one processor that is not a member of an ensemble of processors, to solving the toughest problems across millions upon millions of tightly coupled commodity off-the-shelf processors that shared nothing between each other. Asking a person to become the first programmer of the first massively parallel processing supercomputer was like asking a man who had never climbed a mountain to climb Mount Everest. Because it was considered impossible back in the 1970s and 80s to program the first massively parallel processing supercomputer, nobody took me seriously in my solo attempt to climb the Mount Everest of the world of supercomputers. In my 15 years of supercomputing onward of June 20, 1974, I made mistakes, but I was open to quick course corrections. Those corrections took me to the unknown world of massively parallel processing across a new internet that is a small copy of the global internet that encircles the earth. My new internet is a new global network of 64 binary thousand tightly coupled processors. Each processor has its own operating system. Each processor has its own dedicated memory that shares nothing with each other. Before my invention of the massively parallel processing supercomputer that occurred on the 4th of July 1989, the word supercomputer referred to a supercomputing machinery that is powered by only one central processing unit. After my invention, the word supercomputer referred to a supercomputing machinery that is powered by up to 10 binary million central processing units. I am the first person to discover the fastest computations across the slowest processors. Since my 1989 invention of the massively parallel processing supercomputer, I felt like the ancient mariner who traveled around the world to tell his story and give lectures to different people. My invention of the massively parallel processing supercomputer that is a new internet enabled me to compress 180 years of time to solution on only one processor, and to compress that time to just 1 day of time to solution across my new internet that is my new global network of 64 binary thousand processors that computed in parallel. I invented how to solve grand challenge problems arising in supercomputing and how to solve them in real time instead of taking a lifetime to solve them. I invented the fastest massively parallel processing supercomputer that an oil company can use to reduce its time to market, such as the time between the discovery of crude oil and natural gas in the Niger Delta region of southeastern Nigeria and the recovery of that crude oil and natural gas. For the 16 years onward of age 19 and of June 20, 1974, I conducted my supercomputer research alone. I did so alone because I was ridiculed, mocked, and rejected by all white research teams that were exclusively programming only sequential and vector processing supercomputers. That rejection forced me to forge a different path to the modern supercomputer that solves many problems at once. That rejection forced me to think individually on how to harness the power of the massively parallel processing supercomputer and how to invent the technology and know it for the first time as the engine that drives the modern supercomputer. In the 1980s and earlier, the big question in the world of the supercomputer was, can an ensemble of the slowest processors outperform the fastest supercomputer and change the way we look at the modern computer? In 1989, there were 25,000 users of vector processing supercomputers. I was the only full-time programmer of the handful of massively parallel processing supercomputers of the 1980s. Gene Amdahl and Seymour Cray, the two leading opponents of the parallel processing supercomputer, argued that it will forever remain impossible to parallel process through as many as 8 processors or computer cores. The reason my invention of the massively parallel processing supercomputer made the news headlines and was highlighted in the June 20, 1990 issue of the Wall Street Journal was that the parallel processing supercomputer technology of today was then dismissed and abandoned by the leaders of thought in supercomputing, namely Gene Amdahl and Seymour Cray, and was then rejected by their 25,000 followers, each a vector processing supercomputer scientist. Those 25,000 supercomputer scientists scorned, ridiculed, and dismissed the massively parallel processing supercomputer as a huge waste of everybody's time. In the 1980s, I was dismissed from my research teams and dismissed for advocating the massively parallel processing supercomputer. I experimentally discovered that the conventional wisdom described in supercomputer textbooks as Amdahl's law was wrong. I invented a new way of looking at the computer and solving the toughest problems arising in physics. In the old way of solving the most computation-intensive problems in extreme-scale computational physics, and before my invention that occurred on the 4th of July 1989, the most extreme-scaled algebraic computations arising in physics were solved across a singular, customized, and ultra-expensive vector processor that processed only one thing, or a string of numbers called vectors at a time. That vector processing supercomputer was the fastest supercomputer during the decades of the 1970s and 80s. But in my new way, that is, the new massively parallel processing supercomputer that I mathematically and experimentally invented on the 4th of July 1989 in Los Alamos, New Mexico, United States, I figured out how to solve in parallel the most extreme scale problems that has algebra, calculus, physics at their foundations and as their common denominators. And I invented that technology by parallel processing those grand challenge problems across my ensemble of 65,536 tightly coupled commodity off-the-shelf processors that shared nothing between each other, that I visualized as a new internet, that is a new global network of 2 raised to power 16 commodity processors. In high-performance supercomputing, wizardry is making the impossible to compute possible to compute. The June 14, 1976 issue of the Computer World carried an article that was titled, quote, "Research in Parallel Processing Questioned as Waste of Time," unquote. On the 4th of July 1989, the day I invented the massively parallel processing supercomputer, the 25,000 vector processing supercomputer scientists in the world that were led by Seymour Cray believe that parallel processing will forever remain a huge waste of everybody's time. Perhaps it is only at a very visceral level that you will recognize the father of the modern supercomputer that computes in parallel across 65,000 processors or across 65 million processors. Back in 1989, 25,000 supercomputer programmers abandoned the precursors of the modern massively parallel processing supercomputer that computes across processors or across tiny computers. The leader in the field of the vector processing supercomputer, Seymour Cray, was the strongest opponent of the modern massively parallel processing supercomputer. To date, the brainiest quote of Seymour Cray is this, quote, "If you were plowing a field, which would you rather use, 2 strong oxen or 1,024 chickens?" Seymour Cray would rather compute with 2 strong oxen for the 2 fastest, most expensive, and customized processors in the world. I, Philip Emeagwali, would rather compute with 1,024 chickens for the 1,024 slowest, least expensive, and commodity off-the-shelf processors in the world. As was widely reported, including in the June 20, 1990 issue of the Wall Street Journal, I, Philip Emeagwali, experimentally discovered that 65,536 chickens are more powerful than 2 strong oxen. My scientific truth was controversial in the 1970s and 80s. In those 2 decades, I was banished from the community of 25,000 vector processing supercomputer scientists. I was forced to parallel program abandoned massively parallel processing supercomputers as a lone wolf. As the first black person to win the top prize in supercomputing, and as the only person to win that prize alone, I was devoured like a lamb, and my garments were soiled in mockery. Steve Jobs mocked parallel processing as a huge waste of everybody's time. In the June 10, 2008 issue of the New York Times, Steve Jobs was quoted as telling Apple's worldwide developers that, and I quote Steve Jobs, "The way the processor industry is going is to add more and more cores. But nobody knows how to program those things." Unquote. Steve Jobs continued, quote, "I mean 2, yeah? 4, not really. 8, forget it." End of quote. Philip Emeagwali is the subject of school reports because my contributions changed the way we look at the supercomputer. In the old way and before my invention, we thought of the supercomputer as doing only one thing at a time and doing that thing with only one vector processor. In my new way and after my invention, we think of the supercomputer as doing many things at once and doing those things with millions upon millions of processors. That is, I experimentally discovered how and why the modern supercomputer must compute in parallel in order to simultaneously solve millions upon millions of the most grand challenging problems arising in physics and mathematics, instead of solving only one grand challenge problem at a time. After my invention, the number of parallel processing supercomputers exploded. Before my invention, parallel processing was scorned, ridiculed, and rejected as a beautiful theory that lacked an experimental confirmation. To discover or invent the massively parallel processing supercomputer is to make the impossible to compute possible to compute. I was the first massively parallel processing supercomputers to record the fastest speed, to record the fastest recorded supercomputer speeds, and to record them across a new internet demanded that I visualize my emails as exploding across my new internet. I visualized emails as exploding like bullets out of my eyes. At its granite core, the fastest supercomputer is only fastest and super if and only if it computes in parallel and did so to solve the previously unsolvable. A 12-year-old wrote to me and asked, "I'm doing a school report on the internet. Why are you called the father of the internet?" I answered, "The internet has many fathers and mothers uncles, and aunts. But I am the only father of the internet that invented a new internet. I am the only father of the modern supercomputer who was in major US newspapers and who was profiled for the invention of the massively parallel processing supercomputer. The toughest problems arising in extreme scale computational physics are linked by a common thread, namely the modern supercomputer that parallel processes their extremely computation-intensive floating-point arithmetical computations and executes them across an ensemble of up to 10 million commodity off-the-shelf processors. I, Philip Emeagwali, was the first eyewitness to discover how and why a new ensemble of the slowest processors that computes together as one seamless, cohesive, massively parallel processing supercomputer is a new internet de facto. My invention was how to make a new internet, that is a new global network of 65,536 tightly coupled processors, and how to make those processors invisible individually, but yet visible as one seamless, cohesive supercomputer that solves the toughest problems arising in mathematics or physics. Before my invention, the toughest problems arising in computational physics were inaccurately solved on only one processor that was not a member of an ensemble of processors. After my invention, the toughest problems arising in computational physics are more accurately solved across an ensemble of up to 10,649,600 tightly coupled and commonly available processors that shared nothing with each other. My invention of the massively parallel processing supercomputer changed the way the petroleum industry discovered and recovered otherwise undiscoverable and unrecoverable crude oil and natural gas. My experimental discovery of how and why parallel processing makes the modern supercomputer fastest changed the way we think about how to build the fastest computer. That invention changed the way we solve the toughest problems arising in algebra, calculus, and physics. The now ubiquitous technology of the massively parallel processing supercomputer that was scorned and rejected in the 1940s through 80s is used by practicing engineers and used to increase their productivity and used to reduce their time to market. What will the world be like without the parallel processing computer technology? A world without the parallel processing computer is a world in which 99 of the 100 processors inside your computer is turned off and you are computing at only 1% of your computer capacity. And perhaps achieving only 1% productivity level. A world without the massively parallel processing supercomputer is a world in which fewer discoveries are made. It's a world in which innovation is slowed down. It's a world in which human progress is slowed down. And it is a world in which the computer of tomorrow cannot be invented today, thus making it impossible for us to create the future. faster supercomputers are where science fiction will become non-fiction. The fastest supercomputer is where humanity's future takes shape. To invent a new supercomputer is to create new wealth. The potential benefits to mankind of the fastest supercomputer were highlighted in numerous articles, such as that in the May 8, 1987 issue of the Chronicle of Higher Education that was titled, quote, "Some hail computational science as biggest advance since Newton Galileo," unquote. Fast forward 3 years, the June 27, 1990 issue of the Chronicle of Higher Education published a follow-up article that proclaimed that I, Philip Emeagwali, had made one of the biggest advances in computational science. That biggest advancement was to invent a new internet that is a new supercomputer and a new computer, and to invent them by making the impossible to compute possible to compute. Theorized parallel processing was in the air for the 43 years prior to my invention. The January 11, 1946 issue of the New York Times mentioned parallel processing as science fiction and as 100 computers that could forecast the weather all over the world, and that, quote, the United States would be divided into blocks, penetrating into the stratosphere, unquote. I, Philip Emeagwali, read that New York Times article and made the leap of imagination from the 100 computers that were theorized in 1946 to the 64 binary thousand processors that I theorized 28 years later and that I experimentally programmed 43 years later, and that I used to invent the massively parallel processing supercomputer. For 43 years after that article, that New York Times article, parallel processing was scorned, ridiculed, and rejected as a beautiful theory that lacked experimental confirmation. Parallel processing was experimentally confirmed by I, Philip Emeagwali, and confirmed at 8:15 in the morning of the 4th of July, 1989 in Los Alamos, New Mexico, United States. On that date, parallel processing was verified by the experiment that I executed across a new internet that was outlined by 16 times 2 raised to power 16, or 1,048,576 bidirectional email wires that married 2 raised to power 16 processors together as one seamless cohesive supercomputer that was the precursor to the modern supercomputer, as well as the modern computer. That was the day parallel processing passed the merciless test that I conducted across my new internet. I was in major US newspapers because I provided the lockdown evidence that the massively parallel processing supercomputer can be used to solve the toughest problems arising in extreme scale computational physics. I attracted media attention because my invention of the massively parallel processing supercomputer yielded a measurable and a quantum increase in the speed of computation that became my quantifiable contribution to the development of the modern supercomputer. Making a technological invention demands an intercourse between the sciences and demands the exchange of fluids, or rather, the exchange of knowledge. That exchange is a necessary condition to making a scientific discovery. Scientific babies or new discoveries come from a respectful and joyous exchange of fluids. For me, Philip Emeagwali, that exchange of new knowledge occurred at the crossroad where physics, mathematics, and computer science met, and occurred at 8:15 in the morning of the 4th of July, 1989. That crossroad was where I made the invention that opened new possibilities in supercomputing. It's a myth that only brilliance is required to become a supercomputer genius that invented a never-before-seen supercomputer. Talent is a necessary condition, but it is not a sufficient condition for solving the toughest problems arising in modern calculus and in extreme-scale computational physics. I was asked, "Are you a black genius?" I answered, "The genius is the ordinary person that found the extraordinary in the ordinary. The mathematical genius is just an ordinary mathematician who discovered an extraordinary equation on an ordinary blackboard." I used my new internet to experimentally confirm that 65,536 days or 108 years of time to solution can be compressed to only 1 day of time to solution and compressed across a new internet, that is a new global network of 65,536 tightly coupled processors that shared nothing between each other. I wrote 65,536 supercomputer codes that each solved an initial boundary value problem that arose in extreme scale petroleum reservoir simulation. I message passed those supercomputer codes to my 2 raised to power 16 or 65,536 commonly available processors that shared nothing between each other. And I had as many 16-bit addressed emails that must traverse across my 16 times 2 raised to power 16 or 1,048,576 bidirectional email wires. Email wires that I visualized as tightly encircling the 15-dimensional hypersurface of a hypersphere in a 16-dimensional hyperspace. I visualized my new massively parallel processing supercomputer differently from others. I visualized my new massively parallel processing supercomputer as a new internet. I invented the technology as the starting point of the mass production for the commercialization of parallel processing computers and massively parallel processing supercomputers. I invented the massively parallel processing supercomputer. I invented the technology at the frontiers of knowledge in physics, mathematics, and supercomputing. I invented that never before understood supercomputer as a never before seen internet. I invented the technology by looking beyond my blackboard, looking towards my motherboard, and looking across my new internet that I visualized as my new global network of 64 binary thousand motherboards. Unlike the research mathematician who only looks at his blackboard, I looked across my new internet, and I did so to both theoretically and experimentally discover that my system of diagonal equations of algebra that arose from solving my specific grand challenge problem arising in extreme scale computational physics need not be equivalent to the system of tridiagonal equations of algebra that also arose from solving the same specific grand challenge problem arising in extreme scale computational physics. However, they both must solve equivalent problems in extreme scale computational physics and solve those problems correctly. They both must be equivalent in the governing set of laws of physics from which each system of equations of extreme scale algebra arose. It was across my ensemble of 64 binary thousand processors that I connected with the power of algebra. I was in the news because I invented how to solve the toughest problems arising in algebra, calculus, and physics. At its algebra core, that toughest problem is a world record system of partial difference equations. I invented how to solve those algebraic problems and how to solve them across a world record number of processors. My invention of the massively parallel processing supercomputer opened the door to extreme scale algebra that arises in extreme scale computational physics. The system of equations that I invented were both differential and algebraic. My algebraic equations arose from my differential equations that in turn arose from the laws of physics. Both systems of mathematical equations could be used to discover and recover otherwise elusive crude oil and natural gas. To push the frontier of the fastest supercomputer and thus to invent a never-before-seen computer was to harness the massively parallel processing supercomputer and to use that technology to show that the impossible to compute is in fact possible to compute, and to do the impossible at a time every vector processing supercomputer scientist want that parallel processing will forever remain a huge waste of everybody's time. Throughout history, every inventor entered the unknown world or the terra incognita of technology before the invention became the news headlines. Their biographers or authorized storytellers came on the scene often decades after the inventor is no longer with us. In the 1970s and 80s, I, Philip Emeagwali, was the new and the first massively parallel processing supercomputer scientist that was the lone wolf in the wilderness of the then unknown world of parallel processing, supercomputing. In my vision, and as the primordial programmer of a primal programmer of a primordial internet, I saw those processors as 65,536 equidistant searchlights around a globe. I saw those searchlights as 3,000 square miles apart from each other. I saw those searchlights pointing towards the darkest corners of human understanding of global issues, such as global warming. The massively parallel processing supercomputer was not invented by the team of 25,000 vector processing supercomputer scientists of the 1980s. Those conventional supercomputer scientists scorned, ridiculed, and dismissed the massively parallel processing supercomputer as a huge waste of everybody's time. I conducted the parallel processing experiment that led to the invention on the 4th of July 1989 of the massively parallel processing supercomputer. I, Philip Emeagwali, was the only person who discovered how to harness the total supercomputer power of 65,536 separate processors. I was the first to understand how and why a new ensemble of the slowest processors that computes together as one seamless, cohesive, massively parallel processing supercomputer is a new internet de facto. I had the visceral understanding that the massively parallel processing supercomputer is not a computer per se. I experimentally discovered that my massively parallel processing supercomputer that I visualized as a small global network of 65,536 commodity processors that were identical and that were equal distances apart is a small internet de facto. I experimentally discovered a new supercomputer that encircled a globe in the way the internet does. I was in the news for theoretically and experimentally discovering that parallel processing is an entirely new way of supercomputing across thousands or millions or billions of tightly coupled commodity off-the-shelf processors that were identical and that were equal distances apart and that encircled a globe in 16-dimensional hyperspace and encircled it the way the internet encircled a globe in 3-dimensional space. A discovery is like a stone thrown into the pool of knowledge. The discovery generates wider ripples each time we throw it into the pool of knowledge or apply it. The discovery in science opens up doors in technology and makes the world a better place and humanity more knowledgeable. I'm Philip Emeagwali at Emeagwali.com. Thank you.
Insightful and brilliant lecture.
Thank you.
Insightful and brilliant lecture.